Okay, so today we have the definite integral from 0 to 1 of cos pi t divided by 2 with respect to t. So if I look at this, let's look at the problem area. What is my problem area? Well, my angle looks a bit weird and I want to get rid of that. So let's use U-substitution for this one. So let's say, well, let u be equal to pi t divided by 2. Okay, so if I take the derivative of du with respect to t, I can say, well, that's just going to be pi over 2. Okay, but now I'm going to get dt alone. How do I get dt alone? Well, this is the same thing as du is equal to pi by 2 dt, and then if I divide both sides by pi over 2, this is going to be dt is going to be equal to, this is going to be 2 du divided by pi, because if I divide by pi over 2, I multiply by 2 over pi. Okay, so let's sub in what we have so far. So we can say, well, actually before we do that, this is a definite integral, so we're going to want to calculate the new bounds as well. So let's look at 1 and 0. So if we look at these bounds, this is when t is going to be 1 and when t is going to be 0. So we can say, well, when t equals 0, let's start with 0, you can say, well, u is going to be equal to pi into 0 by 2, and I got this from here, and hence u is just going to be 0. So we know that lower bound is going to stay the same, and we can say when t equals 1, which is from the upper bound, we can say u is equal to pi into 1 divided by 2, and that's just going to be pi over 2. So now we can say hence we have our new integral, which is going to be from 0, the lower bound stays the same, and our new upper bound is going to be pi over 2. So pi over 2. Now we have our cos. We said let pi t by 2 equal u, so we can sub that in, and we also solved for dt, so now we can sub this in. Okay, now what can I do with this constant? This is the same thing as 2 over pi du. Well, if I have an integral, the constant multiplied by a function, then I can bring the constant to the front and take the integral of the function. So this is going to be the same thing as, we can bring the 2 over pi to the front. It's going to be 2 divided by pi multiplied by the integral of 0 to pi over 2 cos u, and then the du is going to stay the same. So now we can take the integral of cos u with respect to u. So we copy down the 2 over pi multiplied by, now if we think about the antiderivative of cos, the derivative of sine u is going to give me cos u. So the antiderivative is going to be sine u, and then we have our bounds. Okay. Now we can rewrite our bounds, and we can get the upper bound, which is going to be sine pi over 2 minus the lower 0. Now let's think about the graph of sine. Okay, so the graph of sine goes 0, 1, 0, minus 1, and then it keeps going. So here's going to be x is 0, here's going to be pi by 2 because this is 90 degrees, and then there's going to be pi, and then so on. So if we think about sine pi by 2, that's just going to be 1. Sine of 0 is just going to be 0. So we get 2 over pi into 1, and that's going to be equal to 2 over pi. So we can conclude that the integral from 0 to 1 of cos pi t divided by 2 dt is going to be equal to 2 over pi. And this is the final answer.